This is Algebra 2, Lesson 7.4, and today we're going to use the quadratic formula to solve equations that are written in general form. So far we've talked about taking equations out of general form and into factored form so we can solve them, taking them out of general form and putting them into vertex form so we can solve them, and now we're going to solve them straight from general form without having to do any converting. The general form equation is right here. And in front of the x squared would be the coefficient that we label a. In front of the x would be the coefficient that we call b, and then the constant term with no variable would be the c. You're going to pull those three values out of the equation and substitute them into this beautiful formula. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. It's beautiful. There are a couple things to consider. One is if you are skilled at your order of operations and your evaluating skills, you should and could do this piece by piece in your formula. If you're not so skilled with that, you could also do this in your calculator in one giant step, but if you choose to do that, you need to add parentheses strategically. So because this is a giant fraction, you would need to separate your numerator and your denominator. And when you use the square root on most calculators, it opens up a parentheses automatically. If it doesn't, you need to add one, but if it puts one there automatically, it's already there. And then because we're opening one for the root, we also close one at the end of the bar for the root. So you could type this whole thing out into your calculator in one big step if you use your parentheses in the right places, or you could evaluate it piece by piece by doing like your exponent first, your multiplying second, your root after that, just your normal PEMDAS evaluating skills. So, too far. I want to be able to see the equation up here. And I'm going to identify what's my A, what's my B, what's my C, and then I'm going to sub them into my equation. So, in example A is 3, B is 9, and C is negative 12. That's the number in front of x squared, the number in front of x, and the number by itself, respectively. We're going to substitute those values in, and I'm going to go just straight across with this formula. So x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So if you are the kind of person who wants to solve it, you would start with this is 81, 4 times 3 times 12 is something else, put those together, root that whole thing, add this to it, and then divide it by that. But I am going to be a different kind of person and sub this whole thing into my handy-dandy calculating device. So to do that, I'm going to start with a parentheses, and I will go negative 9, that was my b term, plus the square root, that was that auto parentheses, so I do not need to add a second one, of b squared, b was 9, minus 4 times 3 times negative 12, that's 4 times a times c. I'm closing the square root, and then I'm closing the numerator of the fraction. Divide it by, and honestly, I know 2 times 3, I would probably just put divided by 6, but you get the idea. So that is my first answer, x equals 1. When we were solving these equations with with vertex form and with factor form, we always got two answers. And that's the whole point of this plus minus symbol here that I didn't really talk about. You do it once with a plus sign, and then you're going to redo it with a minus sign. Keeping all the other values the same, it's going to give you your second answer. And in this case, that would be x equals negative 4. Let's do another one. Letter B. A is 2, that's easy. B is negative 5, that's okay. What is C? the equation has to be equal to 0 to identify the a, b, and c. So basically, I need to take this negative 10 and move it over there. And if I do that, all that's really going to happen is it's going to change signs. It's a positive 10 on the right, so if I do a minus 10 on both sides to bring it to the left, I'm just going to do a minus 10 on both sides. So this is really the same as 2x squared minus 5x minus 10 equals 0. You really can save yourself the hassle of having to do a minus 10 on both sides just by recognizing that if the value is on the wrong side of the equal sign, it's the opposite sign of what it's given. So because I have a positive 10 in my original, my c is actually going to be a negative 10. And that works if your b is on the wrong side as well. If you're, right now my negative 5x is on the left. If it had been a positive 5x on the right, I just know that it's the opposite sign. So I'm going to finish writing these out. B is negative 5 and a is 2. So let's do some subbing. X is negative 5. So a negative negative is a positive. That first term should always be the opposite of the given b. Plus or minus the square root of negative 5 squared. Now I'm going to take a little tangent. On my calculator, if I type negative 5 squared, my calculator gives me the wrong answer. I know 5 times 5 is a positive 25. I also know a negative times a negative is a positive answer. So if I do 5 squared, I see positive 25. If I do negative 5 squared, I should see positive 25, and I don't. Some calculators automatically correct for this. When you stick in a negative, it automatically throws it in parentheses. That solves the problem. So you have two options when you are doing this. I choose the easier option, which would just be pretend it's positive. You could also do it technically correct if you did an extra negative in your parentheses and then you kept going with all your other stuff. I'll leave the choice up to you. So I do have the regular parentheses for my root minus 4 times a times c, double close that, divided by 2 times 2. And I'm going to one-step this guy. Positive 5 plus the square root of positive 5 squared minus 4 times 2 times negative 10, and I'm going to just go divided by 4. I think I got a bracket there. There we go. And I got 3.8. If I change my positive to a minus, my plus to a minus, I get negative 1.3. So I'm going to add a couple more things to note. I think that's the last one, yeah. So if you come up with a domain error or a non-real answer error, that means there is no solution. And don't forget that this value here should always be positive, depending on your calculator. If your calculator throws in those auto parentheses, you're good to go. But I know my school calculators don't, and if you have one similar to mine, it doesn't. So the easiest thing to do is always make that b positive. This b should be the opposite of what you're given, but this b should always be positive. And that's it. Good luck on the exercises, and please let me know if you have any questions.